Continuing with our exponent work, in these notes we'll look at some more properties that exponents have when you are working with monomial operations. So let's get right to it. First of all, we'll look at the power to a power rule, which is what you have to follow when you're taking a power to another exponent. And when doing that, when taking a power to a power, you're going to multiply those exponents together. Now, if there's a coefficient, apply the power to the coefficient normally. So to show you what I mean by that, we have 2g cubed to the 4th, which equals 16g to the 12th. And so remember what this exponent means. It means we have 4 2g cubes. And if you look at it this way, 2 times 2 times 2 times 2, that's where we get the 16 from. And then 3 plus 3 plus 3 plus 3, that is where we get the 12. So when you have a power to a power, apply the exponent to a coefficient normally, 2 to the 4th power, but you can just multiply the exponents together because that's a shortcut to that repeated addition that we see here. So apply the exponent to the coefficient normally, but multiply these exponents together. Now we have the zero exponent rule, which is a little simpler. Anything to the 0 power is 1. So any base to the 0 power, that just equals 1. And then the negative exponent rule. This is where it gets a little tricky. So a negative exponent indicates a reciprocal. So you move that power to the other side of the fraction bar and make the exponent positive. So for example, g to the negative 3rd power, that's going to equal 1 over g to the 3rd. So a negative exponent kind of just means it's in the wrong spot on that fraction bar. Move it to the other side. Now these are all in addition to the multiplication and division rules that we learned in the previous notes. So the product and quotient rules are still in effect, and along with those, watch out for the power to a power rule, zero exponent rule, and negative exponent rule. Let's do some practice here. So x to the 5th to the 2nd power. So here we just multiply those exponents together, and that is x to the 10th. 2 to the 3rd squared. So remember, when you have a whole number base, keep the base, multiply the exponents. 3 times 2 is 6. So you have 2 to the 6th power. So that's 2 times 2 times 2 times 2 times 2 times 2. Which ends up being 64. 2 times 2 is 4, times 2 is 8, 16, 32 times 2 is 64. All right, 5 times negative x to the 0 power. Well, anything to the 0 power, so this whole thing is to the 0 power there, is 1. So this ends up being just 5 times 1, which equals 5. Okay, negative 3/4 w all to the 3rd power. So remember, you're going to apply this exponent to the coefficient normally. So negative 3/4 to the 3rd power. And then the exponents here just get multiplied 3 times 1. So, first of all, a negative times a negative times a negative. So we have negative cubed is going to be a negative. So that's 3 negatives. Ends up being negative. And then 3 to the 3rd power for the top is 27. 3 times 3 times 3. 9 times 3 is 27. 4 to the 3rd power. 4 times 4 is 16. Times 4 more, that's 64. And then w cubed. So negative 27 over 64 w cubed. All right, looking at E, we have h to the 3rd to the 2nd to the 2nd. Well, since these are all power to a power, we can just multiply all of those together. 3 times 2 is 6, and then 6 times 2 is 12. So that's h to the 12th. So just multiply 3 times 2 times 2. Getting a little more complicated here. we'll have to do some simplifying first before we try to do the operation. So take care of the exponents first, right? On the top here we have 3k squared to the third power. Well, so 3 cubed, 3 times 3 times 3 is 27. K squared cubed, 2 times 3, that's 6. So 27k to the 6th over 6m to the 4th times, now let's take care of the other side. 4 to the second power is 16, and then m to the third squared, that's 3 times 2, that's m to the 6th, over, same thing here, 6 squared is 36, and then 2 times 2 here is k to the 4th. Now in the last notes I said that whenever you have two quotients like this being multiplied together, I would multiply them first, and you still can here, but because these numbers are large, if you decide to simplify first, it might make it a little easier. So here 27 over 6, we can divide those both by 3, and that gives us 9 and 2. And then 16 over 36 on this side, we can divide those both by 4, so we get 4 and 9. And that's going to make this a little easier after we multiply. So if we multiply straight across, 9 times 4, that's 36. Then we have k to the 6th, m to the 6th, over 2 times 9 is 18, and then k to the 4th, m to the 4th. And now we can use the quotient rule. So 36 over 18, that's 2. 36 divided by 18 is 2. And then subtract k to the 6th, k to the 4th, that's k to the 2nd. 6 minus 4 is 2. Same for the m's. 6 minus 4 is 2. So 2k squared m squared is what we end up with after that whole mess. So simplify, do your exponents first. Simplifying a little bit ahead of time makes the coefficient work easier. But then multiply across and then divide down. Okay, example G. We've got 4xy all squared times negative 3d squared all to the third. So let's take care of the exponents first, right? 4 squared is 16, and then x squared y squared. Negative 3 to the third power is going to be negative 27, and then 2 times 3 here is 6. And now we multiply these two things together. So 16 times negative 27 is negative 432. And because we have x, y, and d here, those exponents are going to stay the same. They don't combine together. So that's d to the 6th, x squared, y squared. All right, example H. Here we have a negative exponent. So that means that this x is in the wrong spot. We need to move it to the other side of a fraction bar there. So it's indicating a reciprocal. So y though, y is going to stay on top. X squared is going to move to the bottom. And that's as simple as it can get. Can't reduce that or simplify anything else. So that is the answer there. Let's look at example I. Back to using the quotient rule here, just subtract the exponents. So 7 minus 6 for the x's, that's 1, that's x to the first power. Now, something to consider here, if you subtract straight down 3 minus 12, that's going to be a negative 9. And so you know that because the exponent is negative, it's going to go on the bottom, y to the 9th. And if you think about that, this is 3 y's on top, y to the 3rd, over 12 on the bottom. And what happens is these 3 top ones cancel out 3 of the bottom ones, and you have 9 left. So really, wherever the bigger exponent is, that's where the answer is going to end up. So we had y to the 12th on the bottom, and y to the 3rd on the top. 12 minus 3 is 9, but the 9 needs to go on the bottom. And then z to the 7th over z to the 7th. 7 minus 7 is 0, so that just equals 1. That just cancels out. So the answer here is x over y to the 9th. So z's completely cancel. The y's end up on the bottom. Okay, looking at example J, 24 over 36, we can just reduce that fraction. Divide both those by 12, we end up with 2/3. And then we look at each variable. So x to the 5th, x to the 8th, 8 minus 5 is 3, and because the bigger one's on the bottom, that's where they end up. So 8 minus 5 is 3. We've got an x to the 3rd power on the bottom. Same for the y's. 10 minus 4 is 6, but because the bigger one's on the bottom, that's where it ends up, y to the 6th on the bottom of that fraction bar. And this 2, I'll just center it just so it looks better. So we got 2 over 3, x cubed, y to the 6th. So again, wherever the bigger exponent is, that's where the variable ends up. Okay, example K, 75 over 15. This negative sign we can just put out front. Since there's only one of them, we know that it's not going to go away. So 75 divided by 15, that is 5, so positive 5 on top. And then let's work with the variables. So for the p's, 5 minus 3 is 2, and it ends up on the bottom. Now, when you've got a couple negatives like this, you can just subtract them, right? Negative 5 minus negative 4, that equals negative 1. And so q to the negative 1 would end up on the bottom as just a q. Or you can think of it this way. We've got q to the negative 5 over q to the negative 4. You can change those, just put them where they're supposed to be. That's q to the positive 4 on top and q to the positive 5 on the bottom, right? Because the negative exponent tells you it is a reciprocal. And then you can do that subtraction. 5 minus 4 is 1, and it ends up on the bottom like this. So there's a few different ways to think of it. You can just always do straight subtraction and then decide where it ends up based on the answer, if it's negative or positive. Or you can simplify first like this, and then do the subtraction as normal. Either way, that q to the 1st power ends up down here on the bottom of this fraction bar. Now let's look at r. We've got r to the negative 8 in the denominator and no r's on top. So this negative 8 tells us that it needs to go up top right here. So we're going to have 5r to the 8th on the top here. So there's the answer, negative 5r to the 8th over p squared q. A lot going on here in example L. There's a lot going on. So because this entire thing's being squared, what we can do is simplify the inside first because it looks pretty messy. And if we try to square everything in there, it's just going to get worse. So simplify as much as you can on the inside first, and then we can apply that exponent. So we got 5 over 15. That's going to reduce to 1/3. Now let's look at the b's. So this negative 2 means it needs to go to the bottom. So you can think of that, those two are going to go to the bottom and join the 5 that are already there. So that's going to be b to the 7th on the bottom. Or you can think negative 2 minus 5, that's negative 7. So that means since it's a negative exponent, it goes to the bottom of a fraction bar. Either way, we get b to the 7th on the bottom. Okay, for n, 4 minus 2 is 2. That's going to be an n to the 2nd power up top, and we can get rid of the 1 now, since we don't need the placeholder anymore. Okay, then we have z, negative 6 and negative 3. So again, you can just subtract negative 6 minus negative 3. That equals negative 3. And that means we have a z to the 3rd on the bottom of the fraction bar because of that negative exponent. Or just think like these negative 6's go to the bottom, this negative 3 goes to the top, and so you end up with z cubed over z to the 6th. 6 minus 3 is 3, but because the 6 is bigger on the bottom, that's where it ends up. So there's a few different ways to think of how to do this subtraction. No matter what you do, you should get the same answer, which is z cubed on the bottom there. Now don't forget, this whole thing is being squared. Don't forget about that. Once you get this simplified, you still have to apply that exponent. So just apply it to each thing inside. N squared to the 2nd power, just multiply that exponent together. That's n to the 4th. And then 3 squared for the bottom, 3 times 3 is 9. And then for each other variable, just multiply the exponent. So 7 times 2, that's 14 for b. 3 times 2 is 6 for z. And there is your simplified expression here. N to the 4th over n b to the 14th z to the 6th power. So as I said, they can get pretty complicated, but as long as you remember the rules and you go just step by step, try not to look at the entire picture, but if you focus on one thing at a time, hopefully that'll be all right.